Hello everyone, my name is Aidar, and in this video, exercise 2, Basin characterization part 3, I will show you how to do the discharge data visualization in RStudio. First of all, you need to download and install the R and Rstudio, and you need to write RStudio desktop in your internet browser and find the website that's called posit.co, and here you can install R as the first step and then install RStudio. So we click and install R, and here we can see the cran.rstudio.com website, and here you can choose the version for your system. I have a Windows laptop, so I will click on the Windows, and here you need to choose the install R for the first time. If you don't have the R, you click here, and here you will find the link for the download R version 4.3.2 for Windows. We click here, and the execution file will start downloading automatically, and once it's finished you need to click on it. Then the window with the R will appear. It will ask the language first, and then it will have this setup. Click next, and you will choose uh, the parameters for the install, and you just click next. Now when it's finished, you can click on the finish, and you can close this window. And now we need to install RStudio. Click download RStudio desktop for Windows, and another execution file will start downloading. Once the download is finished, we can click on the execution file, and the RStudio setup will start. And now we can click next, install, and the install will start. Once it's finished, we can click on the finish, and we can open the RStudio. We can proceed and open our RStudio, and I will show you quick introduction to the interface of RStudio. And in the top left panel we have the source panel. This is where you write and edit your R scripts, R files, markdown documents, and others. And key features is that here you write and edit your code. It can highlight the syntax, and you can run the code here by clicking this run button. In the bottom left we have the console panel. We have here console, terminal, and background jobs. And the console is where R code is executed. You can type commands directly into the console, and or run code from the source panel on the top. In the top right, we have a panel with multiple tabs: environment, history, connections, and tutorial. Environment tab shows the current working directory, data, objects, and functions in the memory. The history tab lists all previously executed commands, allowing for easy reuse. In the connections, you can connect to the databases in Spark and other data sources. In the tutorial, you can get access to the tutorials for different packages. In the bottom right, we have a multifunctional panel that have access to the files, where you can browse, open, and manage files in your working directory. Plot tab, where you can visualize plots created in your R code. Package tab, where you can manage, install, update, and load R packages. Help tab, where you can see the documentation to R functions and packages. The viewer is to view web content such as HTML files generated by R code or some interactive visualizations that you can create, and presentations that is also presentations that are generated by R. That's all for the interface. Let's go to the next part. And now let's write your first R program in the console of RStudio. And let's write print function. And as you can see, the window appeared, and RStudio tries to predict what you want to write here, and it suggests several available functions that are available under the base uh, package, and we want to use the print function that is available under the base package. In order to use that, you don't need to install any other packages. And we write the print function, and then we put quotation marks, and we can write the hello world. Press enter, and now we can see that this function worked because we have the output of hello world printed in the console. And congratulations, since you became a real programmer, because you have your first working program in R. So let's do the same thing in the script panel. So you can write the same thing, print, quotation mark, hello world, and now we can print, press enter, and as you can see, it didn't print it just shifted the script line to the second line. And in order to make the script work, you need to click on this run button or press on the control enter at the same time. So I press the control enter at the same time, and we can see the result of this console, result of this script in the console. So let's put more exclamation marks and press control and enter at the same time. Yes, and we can see this hello world again. Or you can use just the run button, but it will work only if you choose the certain line to run. So for example, it says here, run the current line or selection. So if you want to run the several lines, for example, like this, you need to select them and then to click run, and we can see the result of 2 lines. Now let's say you wrote your very important script and you want to save that, and you need to just to click on this save button, and then you can write my very first R script and put it save, and here you can see the name and the extension of our script. After you saved your very first script, you need to learn about the comments in programming languages. Comments are like notes or explanation added to the code that computer ignores when running the program. They are solely for human to read. For example, in R, you need to write the hash symbol, and then after that you can write the explanation to the code below. This code outputs hello world, for example, like this, or the explanation to the second part. This outputs yes, something like that. And I would like to compare the comments to footnotes in the book or the recipe. These notes help to explain the text or the recipe to make it clearer to the reader. Notes or the comments in your script are important because they are clarifying complex parts of the code, making it easier for others or yourself in the future, in case you forget what you were writing this code about. Next, I will show you the R Markdown tool inside of RStudio. That is a dynamic document that contains the code chunks where we have our script executed, and the text parts where we write our text without the need of putting the hash symbol as a comment. And here, in order to run the code, you only need to click on this run current chunk, and the whole chunk, the whole code inside of this gray area, it will be running. For example, we have here an example code that contains the dataset cars and visualization for this dataset. So let's click on the run here on the dataset, and we can see the the data for this example dataset, and here we can press run on the plot, and we can see an example plot, and we will be working on the discharge data visualization in the similar R Markdown document. Now you can delete all the containing information right here, and we will start creating our own document. In order to do that, you need to click here on the C, and you need to choose the R. And now we have our first chunk where we will be writing our code for discharge data visualization. First of all, we need to import the data from the CSV file to the R, and you can find the code on how to do that in the book. And let's copy and paste from there. And as you can see, we have here the river information part right here and the load data part. And here we can see the three variables. So what's a variable? A variable are like containers or labels that store information or data, just as a label on a jar that tells you what's inside. For example, sugar or jam. The same way, variable in programming holds data, numbers, lists, text, any kind of information. So for example, here in the variable river name, we store the text Zarafshan. Next, we have the load data, and here we have the variable name, and here is the function readCSV, the function that helps us import the data to R from CSV file, and we need to specify the address or path to the file here inside of the brackets. And how to do that? We need to go to the folder where we store this file. For example, here it is, and in the Windows we can right click on it and select the copy as path, and now we can insert this. Make sure that you have quotation marks inside of it, so the R would recognize it as pass. And next, we need to change this backslash to the slash, since I use Windows and Windows system usually uses backslash for the specifying the path to the files, and our language uses the slash. And here, how can we do it the slow way? And the faster way, we can use the Control F combination on the keyboard, and then here the panel will appear, and here in the find you can type backslash, and here on the replace the slash, and then click all, and after that all backslashes would be changed to the slash. And after that our first chunk of code is ready, and we can click run parent chunk. And as you can see, two things changed. The first thing is our environment, where we have three variables. So here in the tab environment, we would have all the information stored that we assign to variables or tables, data, etc. And we have the next thing, it's an error in read CSV. It says could not find function read CSV. It's a very important error because read CSV is a function that is not in the base R. So we need to install packages that contains more functions. For example, the read CSV functions. What are these packages or libraries? A library in a programming language is a collection of pre-written code that developers can use to perform common tasks. And I would compare packages or libraries to a toolbox, just as a toolbox contains various tools designed for specific tasks. For example, hammer for nails, a screwdriver for screws. A package contains functions and routines for specific tasks. For example, the library for read CSV would contain specific functions like read CSV, so we could import the CSV data. We need now to import the libraries, and we need to create a new chunk of code before the data import, and we can specify here that this chunk of code will be only for libraries. In order to install libraries for the first time, you need to use the function install packages, and here in the codes you need to write tidyverse. That's the package that we need to install, and I already installed it, and it asks to update it. I said yes. So if you already installed it before, you can just update it. And after a few seconds in the console, you will have a message that it was successfully unpacked and installed. And next, to activate it, the library, you need to use the function library, and right here tidyverse, and this one we can comment out, so because we don't need it right now. Run this chunk, and as you can see that this library tidyverse is a collection of several packages that goes inside, and one of them is a reader package, and the reader package is the most important right now because this package allow us to import the data using the read CSV function. So let's run this part again, and as you can see there is no error, and there is a message that specifies how many columns and how many rows we have here. And we can see that the data here appeared in the environment panel. We can click here to see more information, or we can click on the table here to see the data in the separate window. In the next step, you need again to create a next chunk and to copy and paste the following code where we have our data visualized. You can click on the run, and you can see that we have another error saying that we don't have um, find function plot time series, and now you need to install this library as well. And we have this error, could not find function plot time series, and it means that we don't have the package for that, and we need to install the package for plot time series the same way we did with the tidyverse, and we need to change the name here from the tidyverse in the install packages, and we need to remove here the hash symbol, and we just to change to the name the package timetk. We install it first, and now we can see here the message the timetk is successfully installed. Now we can comment it out and add another library timetk. Just click run to activate this library, and now we can run this chunk with the plotting function, and as you can see the result appeared here, and we can see the zero shunt monthly mean river discharge. I just showed you how to do the plot time series mean monthly river discharge visualization, and now I'll show you another example. You just create another chunk, copy and paste the plot seasonal diagnostics code from the book, and now we need to make sure that the variable name of our data is the same that is in our environment, and it is the same as in our data import here, so it's the same. Now we can run the code, and if the previous code worked for you, then the second one will work as well, and other visualizations should work a similar way, and I don't need to show every of them. And if you have questions regarding other, you can contact us, or you can write in the comments or to the website. And thank you for watching this video. Subscribe to our channel. Goodbye.